So welcome to the second video in Chapter 5, the Sedimentary Archives. I want to talk to you about this second factor that affects sedimentary characteristics, and that's the physical, chemical, and biological processes in a depositional environment. Depositional environments are all the places and conditions under which sediments are deposited. By comparing modern sedimentary deposits with ancient sedimentary rocks, the depositional conditions can be interpreted. Remember, the present is the key to the past. Remember that depositional environments can be extrabasinal or intrabasinal. So sediments can be deposited or formed from weathering of pre-existing rocks outside of the basin and transported to the environment of deposition, or they're intrabasinal, meaning that they formed inside the basin, and this includes chemical precipitates, most carbonate rocks, and of course coal. In lab, we talked about there being three broad categories of depositional environment, and you guys worked with continental ones, transitional environments, and also marine environments. Recall that the marine depositional environment includes the continental shelf, the continental slope, and the continental rise, plus the abyssal plain. Notice how this figure shows a submarine fan built of land-derived sediment emerging from a submarine canyon and depositing sediments on the abyssal plain. The continental shelf is merely the flooded edge of the continent. It's exposed to waves, tides, and currents. It's relatively flat and has shallow water. It can be up to 300 kilometers wide, though it averages about 80 kilometers wide. Other aspects of the continental shelf is that it's often covered by sand, silt, and clay, and that the larger sedimentary grains, like the gravels and the sand, are deposited closer to the shore. They can be cut by submarine canyons in the picture that you saw before this, that were eroded by rivers during Ice Age low sea level stand. Coral reefs and other carbonate sediments may also accumulate on these continental shelves in tropical areas. The continental slope is the steep slope at the edge of the continent that represents the boundary between continental and oceanic crust. The water is deeper over at the continental slope, and there is a nice incline. It's very steeply inclined, as you saw in the previous picture. Sediment can travel rapidly down those slopes by dense, muddy turbidity currents. The turbidity currents drop their sediments at the bottom of the continental slope at a place called the continental rise. This area is very deep. It's on the continental rise that we'll see submarine fans form off of submarine canyons. Then finally we get to the deep marine realm, those abyssal plains. These areas are nearly flat, but they're covered by fine-grained sediment and shells of microscopic organisms. These shells are often called tests, and you'll hear about that in historical geology and also in paleontology. But besides these exoskeletons of microscopic organisms, you'll also find clay, volcanic ash, and specifically the types of organisms that you'll see are foraminifera, radiolarians, and diatoms. So I just finished talking about the marine depositional environments, and in the next video I'm going to look at those transitional environments.